All right, moving on to the next set. All right, so we are going to graph each equation, but we're going to find the vertex and the axis symmetry at first, and then we're going to figure out these values, and then we're going to graph it here. I'm probably going to run out of room, so because I'm going to write notes off to the side, so you're going to watch me erase a lot, so just bear with. Write the notes wherever you can or on a separate piece of paper. There's not a lot of room, but we'll make this happen as efficiently as we can. Okay, so what we wrote on the other page was, oops, made a mistake, that this is the vertex form. And the axis of symmetry is x equals h, and the vertex is x comma h. And not x, I meant h comma k. Okay, there we go. So that's information from the other page. I'll highlight it so you have it. Okay, so let's try to find the axis of symmetry. Well, we know that if there's an addition sign, that's the same thing as subtracting a negative. And I will not be writing this much longer. So if it's adding, this value is actually the opposite. So it's the opposite of what you think. Okay. So x equals -2. So that means right here we're going to put a -2. So we already have the x value of the vertex. Now I have to find the y value. What's in here is always the opposite. What's in here is always added or subtracted at the end is always the same. And what I mean by that is it's going to be a +7. So we already know at -2, 7, we have a vertex. Then my next question would be, so I want you to find the axis symmetry, find the vertex, and then for step 3, I want you to ask, is it opening up or down? Well, because there's a negative sitting in front of that parenthesis right here, that means it's going to open down. So it's opening down. So that means these y values from here to here should be decreasing. If they're not, we did something wrong. So we're just going to pick x values. I'm going to decrease my x values and then increase them. And we're going to plug in these values into this equation. So I'm going to make a makeshift table over here, and then I am going to eventually erase it because I need to write some information down for you. Okay, so let's just start from the top so it's just easier to calculate. X equals -4, and we're plugging it into this equation. So I'm actually going to write this here so you can see what I'm doing. Okay, so x is going into there. So we have 4 plus 2 squared. 4 plus 2 is 6. 6 squared is 36, and then we drop down the negative, plus 7. Okay, I made a mistake. The question is, where did I make the mistake? Where did I make the mistake? Well, I made it right here, okay? Yes, I did it on purpose. I wanted to see if you followed along. This is why negatives are so important. You have to be very, very, very careful with those negatives. So I did not put a negative there. Okay, those negatives make a big deal. So we actually have -4 plus 2, which is -2. -2 times -2 is +4, but that negative drops down. So -4 plus 7 is +3. Okay, 3 is less than 7. The value is decreasing. Okay, I'm going to make a line to separate this. All right, now we're going to plug in -3. Plugging -3 into this x. So -3 plus 2 squared is +7. -3 plus 2 is -1 squared. -1 times -1 is +1. Drop down the negative and you get 6. Okay, now what we know is because this is the axis of symmetry, it cuts right here. These values should be 6 and 3. I still want you to calculate it, but for time's sake, I'm not going to. You should be able to do that. We did this in the beginning of the year, so I should be able to handle it. From there, I'm going to plot these points. So we already have the vertex right here. I'm going to put in -3, +6, -4, 3, just using the points from the graph. And then we have -1, 6, and 0 is 3. Notice how these are symmetric. They're equal distance where this line would cut in half. So this is our parabola. And I'm drawing this really horribly. Let me try again. Quick question. Wherever it crosses this line right here are the solutions. What else are they called? They're also called zeros, because it would be y equals 0. Okay, just had to throw that to a previous section to make sure we're working on it. Okay, so the next thing I'm going to ask you is domain and range. So domain for quadratics is always going to be all real numbers, okay? So no, that means all real numbers. Some of you are writing that down wrong in your daily practices. The range is asking you what's the lowest value to the highest value. That's the highest value right there, okay? And that's because it has a max. This is the max, right? So the lowest value is going to be clear down here. Okay, so the highest value is this vertex value of 7. So y is less than or equal to 7 because it goes down. So if you notice, this is the setup for maxes. Maxes will always be y is less than or equal to some number. Mins would be y is greater than or equal to some numbers. Okay, so let's compare this graph to what would be the parent function of y equals x squared. And let's try to go over some of the transformations. So I'm going to, I know there's a lot going on. Actually, I want to use this with a different color. I want to make a line, a box right here. Okay, and in that box, I'm going to put what the transformations are. So that way I can kind of break up my information. So what are the transformations? Well, I'm going to tell you there's 3 transformations. So I want to put a little dot there, and a little dot there, and a little dot there. All right, so let's compare what these transformations are. Okay, so we have this graph. This is what we just graphed, and the red's the original. So I'm going to ask you yourself, did it move left or did it move right? Well, it moved left, right? How many did it move left? Well, this vertex was here, and now the vertex for the x value is at -2. So that means it shifted -2. The connection there is that the axis of symmetry is -2, so that makes it move left 2. So that's one axis, or one transformation. Now I'm going to ask you what the other transformation is, and I'm just going to ask the vertex. Notice how this vertex y value is at 7, and this one's at 0. So that means this graph went up 7. So the 7 added right here is making it go up 7. So right here, up 7. All right, and last but not least, the original graph is opening up. This graph is opening down. So since it's opening down, that means it's reflecting, and that's because of this negative right here. So it's reflecting, or reflected, and that is because of this right here. Okay, that makes it reflect. All right, I'm hoping you're writing this down. I know there's a lot going on, but this will help you look back at, obviously you have the video to do that too. Okay, so let's look at number 5. I would like for you to, on your own, figure out what the axis symmetry is. I'm going to highlight it. Let's make it blue. I want you to find the axis symmetry. Oh, that did not look good. Let's try it again. I want you to find the axis symmetry, and I want you to find the vertex, and then I want you to tell me, does it open up or down? So step 1, step 2, step 3. Okay. So go ahead and do this problem on your own. If you get stuck, restart it. If you finish it, restart or start the video back up. All right, so go ahead and pause the video now. All right, now that you restarted the video, in the meantime, I was kind of rearranging this because I didn't like the way it looked. Okay. Sorry, still cleaning up. Okay, so this is x minus 1, which means that is the h is just 1 because the rule says it's negative. You take it as is. If you notice, it's always the opposite. If this is -1, this is +1. If this is adding, it's negative. Okay, so this is always the opposite. And while I'm thinking of it, while we're kind of on that frame of mind with this x value, what does this value make it do? Okay, so up here this was +2, which meant the negative was, this was -2, and it moved left 2. So this is x equals -2, and it moved left 2. What is this x value going to do? Okay, we said it's x equals 1 because that h equals 1. What is this going to do? Originally be at 0, 0, and now it's going to be at 1. So it's going to move right 1, and I'll show you that in a little bit. But I'm just starting to try to do this without having a graph. Okay, there's nothing added or subtracted. So I told you on that other problem it's like plus 0. So if there's nothing added or subtracted, the value is 0. So you have a vertex of 1, 0. Okay, and then the third step I asked you was, does it open up or does it open down? And how do we figure that out? Well, we look at what's in front of the parentheses always. Okay, and it's a 3, but it's a positive 3. And if it's a positive number, it's going to open up, which means from the vertex, as we go through these values, they should increase because it's going to be opening like this. So the y values will increase off of it. Okay, so I'm going to use the value of 2 and 3 and 0 and negative 1. Okay, and I'm going to calculate them over here because I didn't leave a whole lot of room. So we have negative 1. I'm plugging it into this equation, so I'm just going to rewrite it here so you can see what I'm plugging into. This one's a little less work, and there's no negative, which causes a lot of issues. Okay, so we plug the 0 into here, and we get 0 minus 1. Well, we all know that's negative 1. Okay, and negative 1 squared is just 1. So this is 3. Since this is the axis of symmetry, and it cuts it right in half, what is this value going to be? Well, if you said 3, then you're right. Now, I would like for you to calculate it just to be safe. Actually, hold on. Did I do something wrong? Oh, guys, I did the wrong problem. Oops, 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 oops. That time I did not mean to do that. Okay, so the 3 actually goes here and here. And the reason is because I did not plug in negative 1 into here. What did I plug in? Wow, mistakes, people. It's because I haven't had my coffee yet. I plugged in 0. See that? The 0 took the place of x, so I actually did 0. So, back up. If you plug 2 into here, 2 minus 1 is 1, and then you're going to get 3. Okay. So, these two are the same, and we're good because they increased. So, now let's plug in negative 1. Sorry about that. I did not mean to do that. I did not mean to confuse you that time. Okay. That time, keyword, we're going to actually plug in negative 1 now. So we're going to do 3, and then it's negative 1 minus 1 squared. Negative 1 minus 1 is like adding a negative. So you get 3 times negative 2 squared. Negative 2 is 4, so this is 12, which, yes, is off the graph, and that is perfectly okay. So we're going to graph this. We have a coordinate point at 1, 0. That's our vertex. At 2, we go up to 3, and at 0, we go to 3, and then we're off the graph, so I'm not even going to try, and it looks something like this. And we're off the graph because that 3 right here stretches it. It makes it move a lot faster. I'm going to show you. Every time we do this, and there's a value in front of here of 1, the first 2 points are off by 1. But do you notice how these ones go off by 3? So they grow. Okay, every time we do this, I swear, if there's a 1 in front of here, the next value will be 1 off, unless there's some weird stuff going on, but there's not. This value is 3, so right away it goes up by 3, and then it's going to continue to grow, right? So right here, that's a transformation, and that's a transformation, and I'm going to prove it to you once we do domain and range. Domain is always, always, always all real numbers. This thing's going to keep stretching left and right. Okay, this right here is called a what? It's called a minimum or a vertex. Yes, minimum's what I was looking for. Because there's a minimum, we said right here, so much highlight going on, I bet it's this crazy. It's going to be y is greater than or equal to whatever that y value is. So it's going to be y or greater than equal to 0. I'm going to ask you one more question that's not on here. My question is, what is this also called? Well, that's also called a 0, so that means the solution is actually x equals 1 if we were to solve it. Okay, so let's compare over this graph to our parent function. So right here, this green line, that reminds me of Christmas colors. We're not doing Christmas colors. Okay, there's a way. I can't do orange, that looks goofy. Okay, so we have this blue line, and we have the red line. Our red line's our original, it's like the parent function like we talked about, and the blue line is the graph that we just did. Okay, so 0, 0, if I ask you if it moved left or right, you're going to tell me it moved right, and it moved right by 1. And just to prove, I wrote that right here, right 1. So we need to make a thing for our transformations. Okay, and I'm going to run out of a lot of room. So transformations, I'm going to write it right. I don't want it to be red. Do you not see that I have it picked right there? I guess I might have to just go with red. Whatever. Okay, so transformations. We already said it was moving to the right 1 unit. And that is because of this x equals 1. Okay, the vertex is usually at 0, 0 to start, but ours is at 1, 0. And if we notice again, it shifted to the right. Now, did it shift up and down? It didn't. And the reason it didn't is because there's nothing added or subtracted after this set of parentheses, or the x squared. So because there's nothing here, it's not moving left and right. But I am going to show you how this graph is moving. So if I took away, let's do it this way. What if I did 3x squared? Okay. I'm going to change this color, if it lets me. Okay, so the black is our original, okay? And this is our new graph that I just made up. Do you notice how this red graph is moving so much faster than the black graph? Well, if the number in front of the x squared is bigger than 1, then it's going to vertically stretch it. Okay, so let's write that down somewhere. Okay, so ignore all this stuff over here. So let's make a box, kind of like we did on that last one. And I don't get why it won't let me change colors. Let's see if it'll let me do it this time. There we go. Okay, so write this down somewhere, put a star around it. And we're going to have another place we're going to write this, but it's okay. So A is greater than 1. Okay, so we're talking about the number in front of x squared. So front of x squared. It's going to make it vertically stretch. Okay, the question is, what if it's less than 1? Okay, and there's a better rule for this, but this is just kind of what we're going to go with. Okay, so what if I made this, and I know I'm getting off on a tangent here, 1/3. Well, doesn't the graph get flatter? Okay, what if I made it like 1/9 or 1/10 or 1/30? Do you see how much flatter it gets with each move? Okay, if it's a fraction that's less than 1, then it's going to make it flatter. And the key word there, if it's a fraction that's less than 1, it can be a decimal too, so let's be careful there. So like I can also do like 0.25, but that's still less than 1. If it's a fraction or a decimal less than 1, it's going to vertically shrink it. So it's going to vertically shrink. Now I'm just going to show you something. If I did the fraction of 4/3, 4/3 is more than 1, and you notice how it's going faster. Or if I did like 7/3 or 13/3, it's stretching it, right? It's a fraction, but it's more than 1. Okay, so it's very, very, very careful to be with that. So the whole point of me showing you this was to work with this example. So let's get back to it. So this is vertically stretching it, and then in this example, we have this. So it's stretching. Okay, I just moved it over to the right. So I had this graph, the red, and then I put the -1, and that moves it to the right. So this is vertically stretching it. So the 3 in front makes it vertically stretch. And I would like to ask you to how much. So by, and then whatever number is in front, 3. So if it's 1/3 or if it's 1/4, you'd write that there. So by 3. Okay. So this is a lot. And we're going to kind of go more into it in this next example. And we're going to just more focus on the transformations. Okay, I didn't ask you in this problem to do the transformations, but I wanted to start getting into it because the more examples we have, the better it is for you. Okay, so the most simplistic quadratic function is f of x equals x squared or y equals x squared. Remember, those two are the same thing. F of x and y are the same thing. As we've been talking about, and I kept mentioning it, this is the parent function, okay? And a transformation is either a change to the size or shape of a figure. And I'm also going to add location, okay, because it can also be like where it's at in a graph. Now, transformations you're going to see a lot in geometry, and they're going to be a little different of how you do it, but this is a good introduction to it. Okay, so if you notice on this one, it says graph each function, describe how it compares to this parent function. So we've already been doing this, but this is more practice. Okay, we're not actually going to do this table. Actually, we'll do 3 points of the table for some of them, but not all of them, just to get you used. So what you need to do first, okay, these are your steps. Step 1, it's going to let me write. Okay, step 1 is to find the vertex. So that's x equals. Step number 2 is going to be the axis of symmetry. So that's a coordinate point. And then step 3, I want you to tell me if it opens up or if it opens down. Okay, so remember, if there's nothing added or subtracted, it's like plus 0 at the end. This is positive, so that really makes that h value negative. It's the opposite of what you think. There's a displacement thing going on, like displacement with water, okay? So like when you put a heavier object in it, the water rises, okay? It's kind of a displacement with this, but in a mathematical way. So the vertex is -2. So we already know that this thing is going to, because of this, shift left 2. And I'll prove it, okay? And then we have to figure out what the y value is. Well, there's nothing added or subtracted, so the y value is 0. So because this is 0, it's not moving up or down, okay, because of this. Oops, explanation point. Because of that right there, all right? And then the next question is it opening up or down? Well, there's no negative, so that means this thing is opening up. Okay, so we have -2, -1, and 0. So we're going to plug in those values because this is the axis of symmetry of the vertex right here. These values should be the same. So I'm going to make a little table. Okay, we're going to kind of get away from that in a few seconds or in the next video because we're going to try to just think of the transformations without graphing it, but I'll still show you for those visual learners. So I'm going to pick 0. I'm going to plug it into this equation, which is x plus 2 squared. If you plug 0 into the x, you get 0 plus 2, which is just 2. So that's 2 squared, which is 4. Oh, I see what I did there. Oops. Hold on. Let's ignore that value. Ignore that value, ignore that value. Because I didn't do math very well. Okay, so I don't want 0 unless I want it here, which is going to be 4 there. Because this should be, oops, I'm still writing in the wrong place, sorry guys. This would be -3, -4, and this would be -1, 0, which means that would be 4, and this -4 would be 4, which we don't really need. Okay, so ignoring that, let's plug in -1. So we plug in -1 into here, you get -1 plus 2. -1 plus 2 is 1, squaring that is 1. So this is 1, and that would be 1. Do you notice how it's increasing? Okay, as we go through these values, oops, increasing, and that's because it's opening up. Right, and you notice how it goes off 1 and off 1. That means it's not stretching or shrinking by anything because of this right here. Okay, if it goes up by more than 1 or goes down by more than 1, then it's shrinking or stretching. Okay, so it went left 2. So we have a coordinate point of this, and then we'd have -1 and 1, and that's all I'm graphing. So the graph looks relatively the same. The only thing it did is it moved over 2. So that is our only shift. Okay, and I'm going to prove it to you real quick. So we have x plus 2 squared. Okay. So this is the graph that's the parent function, and this is what we just graphed. And if you notice, the only thing it did is it moved left 2. So that is the transformation, left 2 units. All right, that's the end of the second video. In the left-hand corner, I'll have a link for you to go to the third video. Go ahead and please go to that to get more help because this is extensive stuff that you'll see for a while. All right, thank you.